whatever we have, and then we have walk inside we have, and then we have mobile worker is that. So we can have simit as a walk inside, and we have to automation whatever we can able to do it with automation. We have is there. So other automation whatever you have you like to do it, so we can able to do it. So in this we can going to see about that simit and then walk inside and mobile worker. So first we can see about that simit. So previously we have seen about that comas, how it is working like that. So simit is mainly for a simulation purpose. So here we can do the simulation from that comas PNIDs. We can able to send a data exchange from that simit, and then simit can send a data to comas. So how the real time values are virtually running values can be, we can able to link with that comas. So if level transmitter is showing that tank level is 50%, 100%, that all data can be also transferred to that comas. So comas can send a PNID to simit. So like that it will be a data exchange platforms. So now we are going to see about that simit. So previously we have seen about that all how we can able to create a comas data. So once you done with that simit, so simit simulation after that they can send the data to comas also possible in this. So main functions of simit is importing that PNIDs from that comas. We can able to import it, and then we can able to train all the equipments how they work for engineers, fresh engineers they can able to train in this. So and then we can able to virtual commissioning of an plant with that PLC. So if you have any PLCs, we can able to run that virtual plant also possible in this. So mainly these are the things. So components in that simits are chem bases are there, and then communication libraries are there, connectors are there, drives, flownet and standards are these types of libraries are there. So under that each libraries they have multiples of subdomains are there. Mainly chemical basis library will have that all the tanks, valves and then separators, pumps, heat exchangers, burners, fittings, all the things will be comes under that chem basis. And then communication oriented will have that mainly that which are having that controller which have communication oriented things which will be schematic managers. So and then we have a drives, connectors are there, so which will be mainly used for connect that PLC input data to your simit data. So while you are using that input means from PLC if you are getting some inputs we can able to use that input data. So output data from that PLCs which are used to connect with that level transmitter, or you can use to connect with that pump drives, motor drives or anywhere, so we can able to use in this. So and then we have a mainly we have a connects and then drives are there, flownet libraries also there. So mainly these are the some graphical views of that components. So pump you have tanks, there are different types of tanks is also there, separators is there, RO systems like that we can able to drag and drop, and then we can able to create it PNIDs like this also. So this is one of the PNIDs which will have a 4-tank system which will be from that reservoir tank it will be given to that 4 tanks. From there we can also able to get all the measurements from of the tanks using that measurements. So while you are using these measurements, and then we have a motor driver controls. So here we have a signals. So these signals are coming from that PLCs. So the pump has to be run or not, and then set point at what range it has to be run, like 0 to 100. So at what range it has pump speed has to be varying, like that all the data can be coming from that PLCs. The signals all this are in the connectors. So while you are using that input means it will be giving that input signals. If you are giving output means it will generate output signals like that. So we can able to connect it with that motors. And then we have a simit tanks is also there. So if you have all the data, we can able to enter in this parameters also. So in that bottom itself, once you select that pump, you can have all the parameters. So which can also, we can able to enter it in that SIMIT itself also. No need for go it for SCOMAS, we want to enter all the data. If there is a inbuilt data, it will automatically updated here. If you are creating a PNIDs in this, you have to enter all the data manually. So what is the capacity of the tank, what is that pump speed, all the things can be, you can able to enter. So if you are varying the pump speed, if you are changing that pipe size, so how it will be happening, all the things can be, we can able to done that in simulation mode itself. So major another thing is in SIMIT, we have a CTE is also there. So CTE is while you are installing itself, you will get about that mainly you will get these three, SIMIT and SIMIT SP demo CTE. So these three you can get it. So here CTE is mainly for component editor. So SIMIT SP is an original software. Here we need a license for open this one. So I am just going to use that SIMIT SP demo. So in this demo also there is some limitations like 30 use IOs we can able to use, and then 45 minutes we can able to run it in this. So otherwise we need a license to do the simulation, all the things. So if there is a no limit switch also, we can able to create a limit switch in that CTE. So in that components library we doesn't have a limit switch. So high level limit switch, low level limit switch also we can able to generate and create it in CTE. So for that we need an CTE. Under that we have created blocks like this. So here we have analog input, and then read that analog input, how much it reads. So depend upon that process value, once it will reach the 60%, so it will generate a switching as an true. So then it will have that limit switch process. All the things can be, we can able to create it in CTE. So we can able to create difference between that this is an all comes in real plants, this is in virtual plants. So the real plant will have that all the IO real devices like differential pressure transmitter is a Citrain based Siemens differential pressure transmitter is really they have in that simulated device they have a Citrain based heart communicator differential pressure transmitter is also here. So in that library we just take that DPT differential pressure transmitter, so it will simulate that virtual values, where here we have a real values in that SIMIT. All the things can be, we can able to communicate, and then we have a communication protocols available in that SIMIT and so virtual controller is there, PLC SIM advanced, and then we have a OPC UA, OPC DA and UA client here, all the things is there. So we can able to connect with, and then we can able to do the simulations also possible in this. So mainly we have a hardware in loop, means it will have that real hardware like PLCs which is having in this types of S7200 PLC. So in virtual we are going with that PLC SIM advanced, so which will be a virtual controller which will not have that real hardware. So through that also we can able to couple with that SIMIT and then do the simulations also possible in this. And then we can able to integrate with that COMAS PLCs and then SIMIT also. This is how we can able to send a COMAS PNIDs to SIMIT PNIDs, whereas we have a SIMIT interface is there in that COMAS. So through that we can able to export that SIMIT. Through SIMIT export we can export the data. From there here modeling we can able to import that whatever that we have created in that PNIDs, it can able to generate it in that SIMIT itself. So through that we can able to run parallelly, and if you want to create a new diagrams in SIMIT also it is possible in this. So we can able, what are the some benefits of using that SIMIT is we can able to train that priorly. So before itself we can able to train, before the plant startup we can able to train the operators, and then we can able to improve that fast commissioning. So when you are doing that simulation, all the things we can able to commissioning it fasterly, and then for a safe and efficient trainings also we can able to do it in this. And we have another thing is an COMAS walk inside. So which will be an comes under that life cycle platforms. In COMAS we have given that there is a majorly 4 platforms. That in that we have last platform which is an life cycle. Under that we have a COMAS walk inside. So mainly COMAS walk inside will have that 3D visualization of an entire factories. So once you have that in 2D oriented things will be available in that COMAS platform. So if you want to walk through that entire plants, we can able to walk through in that plants like this is an one plant. Here we have some pumps which will be that pump, and this we can able to navigate from that PNIDs to directly to that walk inside. So where it will be located. So all the things also we can able to find out in this. So we can able to walk through entire plants, and then if you want to train the employees also possible. So first thing we want to create that entire plants. So how we can able to create that entire plants? So for building that entire plants, there are 2 ways is there. So one is for greenfield, another one is for brownfield. So greenfield is for those who are going to create a new plant. Before that itself we are going to get all the data, means from there EPC modules we can get that all the 3D models. By that we can able to build that. So for brownfield all are 2 old plants. So for that plants all the 3D models we doesn't get it. So for the old plants we can able to get it from laser scanning, and then photogrammatics also possible in this. So while we are scan that entire plants using that lasers, after that we will get some data. Through that we can able to compile it and then we can able to create a 3D models of that entire plants also possible in this. So for existing plants also we can able to generate that all the things. So here we can able to train using that COMAS also. So here we can able to do the operator trainings in the 3Ds also. So before going into that plant, they can able to train in different scenarios. How you want to check that valve, how much the valve pressure is there. So operator training scenarios we can able to implement in this. And then if you want to do the safety scenario oriented things also possible to do in this. So after that, that pump will be open. So like that, all the things we can able to do it in this virtually. So train that operator before they enter into that plant. It will gain that operator's knowledge more. So after that, finishing of that, that report will be we can able to generate it from here. So in walk inside. So which will be more useful to get all the how that operator performance, all the things we can able to sort it out before they enter into that plants. So safety oriented scenarios also possible in this. So if you want to create a fire in your factory, oil leakages, gas leakages, so all the things also we can able to generate in that walk inside. Through that also they can able to get all the information what he has to do in that safety scenarios, all the things also possible in this. So and then we have some benefits using that immersive training. We can able to train without a programming skill also. We can able to train easy to use these softwares. So we can able to build a without a CAD models also. We can using that laser scan, all the things also. We can build that CAD models, walk inside models also possible in this. So last, and then we have a COMAS mobile worker is also there. So in mobile worker mainly used for creating mainly used for operational efficiency and reliability, and then maintenance oriented things, and then reduce that paperworks to unlock to digital works. They can be changed over to that. Everything will comes under that in your mobiles like that. So in your Play Store there will be a Ubiq is an software. So you can able to download it and then you can able to view. I think so. Ubiq in your mobile you have a software. So through that they have one demo plans also there. So you can able to view that one also. Ubiq. This is a mobile worker software which will be available for a COMAS. So that will reduce that manual entering of paperwork. All the things can be uploaded into your mobile. So through that while you are doing that SOPs, what are the standard operating procedures, daily up-to-date current values, all the things once you entered in your mobile, it will directly updated in your database. So it will be having that reduce your works, all the things. And then for maintenance oriented things also, it will have all the data. So how the if you have a many, it will reduce your field workers. So if you are only if you have some only one field workers, it can able to this is like that. So while you are entering into that factory, while you are searching with that, you can able to find out that this pump and all. So once you select that, how to do the maintenance oriented things, so where you want to change all the things, so easily we can able to navigate. So this is in German, so it will be some languages. So what are the procedure to do all once you done or not, so we can able to do it with the tick or wrong. So easily we can able to sort it out. And then if you want to do the maintenance, all the things also, the video will be available in that. So through that we can able to do the maintenance oriented scenario using that AR availability in that COMAS also possible in this. So benefits will be, there will be everyone will have that correct information. There will be a bi-directional flow. We can audit your factory at any times. So this will be easy for in that field also. Mainly these are the things available. Advantages in that COMAS mobile worker. So which will be having that Ubique software in Play Store. Anyone can download and then they can use. So there must be, we have to upload your plant data. So for that demo purpose, we have one plant demo data. Through that we can able to watch all the things. Or you can have it in Windows also possible in this. In Windows also we have a Ubique software. So while you can download it and also we can view it in your PC systems also possible in this. So this is one use cases for easily to demonstrate. We have one demo setup which will be available in our factory. So this is one main tank. So and then we have a reservoir tank. From that we have a pump. So from that pump, varying that pump speed, we can fill the tank level using that level sensor. So this can be, we can easily we can able to create a digital twin. So components used here is an capacitive type level sensor. We are having that variable speed pump, and then SCR is having. So this is an how real hardware is connected. So here we are using this controller as an Siemens S7200 PLC. So from there in that PID controller we can given the 4 to 20 milliamps output to the SCR driven board. It will vary the pump speed by 0 to 220 volt AC, and then that level transmitter will give that 4 to 20 milliamps to that PID controller. So through that it can absorb and then control, maintain the level in the tanks. So this is how that real hardware works in that. So for virtual commissioning also we can able to do it in SIMIT, and then we can able to integrate with that walk inside all the things. So virtually we can able to create a COMAS PNIDs, and then we can able to import it in SIMIT. So and then we have a PLC. For that PLC also we can able to use in that PLC SIM virtual controller. So from that we have write a programs using that TIA portal. So all the data can be transferred. So we can able to run it in virtually also. So virtual mode we have developed that CAD models of that simple plant in virtually. So through that we can able to walk through all the things. So this is an COMAS PNID, and then this is an SIMIT PNID. So COMAS, once you entered all the data, while you transferred into that SIMIT, it will get like this. So COMAS we have like just 2 tanks and then pumps. So while you transfer into that SIMIT, it will get all the data, how to simulate all the things. So once you link with that SIMIT, and then we can able to find out all the, we can able to run this one also. So while you are running this, we can able to find out what type of, how much level is available in that tank. So all the things can be, this is an VR part of that plant, and then we can able to integrate with that AI using this digital twin models also. So using that edge impulse, we can develop AI models also. So we can able to collect the information, and then train, and then we can able to test and deploy it. So mainly we are using that real-time data, real plant having that sensors oriented data. So from that we can able to train that in edge devices, any edge modules, and then we can test and develop in the deploy in that Raspberry Pi controller. Through that the Raspberry Pi will have a OPC UA communication protocol. Through that we can able to test it in SIMIT. So SIMIT will have a communication protocol of OPC UA. So before all the things in that area automation, we are using that PLC. So for testing that predictive maintenance and then AI implemented oriented things, for all that we have used that controller, automation controller using as a Raspberry Pi. So once you deploy that tested all the things, you can able to test it in that simulated modules itself. So it will run in your SIMIT modules. So you can able to test that that result will be correct or not. So whatever that you can get it from that AI, all the things can be, we can able to test it in that virtual mode itself. So no need for going into that real plant. So if you are all the algorithms which are put it in that developed and then put it in that controller which you want to test it in real plant can be reduced in this SIMIT using this digital twin also possible in this. So this is what they can develop and then they can able to implement in this. So from there I will stop. If you have any doubts, you can ask. Otherwise, we will have just how to create some models in that SIMIT, and then we can do it in this. Yeah, 3 is there. Yeah, SIMIT, CT is there, SP demo is there, SP is there. SP. Own component means no. We can able to create with your library. If you have any without components in that libraries only, we can able to create using that CTE. We can able to design a plant. So if you want to design a heat exchanger, it is not possible in that. So there is some valves is there. So tank is there. So if you want to change the tank shapes, so it will have some fixed shapes and then different volumes. So if you want to change that shapes, that will be you need to create using that CTE. Yeah. So if does not CTE, if does not you have a CTE, then COMAS will do that. While you importing itself, it will automatically generate all the data. Change the dimension. Size we can able to do it in this CT, not in SP itself we can able to do. CT is I will just show, then you can able to get it. So I am just creating one here. So just open that project view. So here is nothing is there. So I am just creating a new chart. So in that charts, so these are that so these are that available components. So which were not having in this components, we have to create it in CTE. So if you want to edit this component, if you want to use this, you can just Basis libraries. So if you want to change this one into a different shape, all the things only you need it. If you want to enter that volume or length, change that volume by 100,000. Like if you want to change that length by 50. So all these things also possible in this. If you want to change that drum shape, all the things only you need a CTE. So if you want to edit that inbuilt shapes and then all the things you need a CTE, all the things. So if you drag and drop that models, in that you want to change that volumes or length, width, height, all the things can be possible in this. Simit itself you can able to do. So you see, if some walls are, if you want to do that, some walls you need globe wall, what different types of walls you need. That means if that wall is not here, control wall, gate wall is here. So if you want different types of gate wall, globe wall, it will be not available in this. Means you have to create it in your CTE like that. So for mainly it will have basics walls only. So it will not have any types of controllers on like this. So for all that you need to create in your CTE like that. So it is a motor controller or it will be a plunger type, or all the things can be able to generate in CTE. So valve sizes we can able to edit. There is no flow. What is there is any flow is available? What you are asking? I don't understand that. There will be a flow, all the things is there. So it is will be a just a manual valves, or it will be a just a signal valves like 4 to 20 milliamps you have to generate, like that valves will be there. So you can able to give that data, all the things valves is there. So if you want to change that valve into that pneumatic valves, so like that it will be not possible in this. So these are that manual valves. So if you want to change it into that signal based valves also possible in this. So here we have signals which will be coming from that controllers also possible in this. So from connector I have an input. Sorry, it will be output. So from that output we will connect with this valves. So this is an signal which will be sending that sending from that PLC, so which will be connected with your valves also possible in this. So here we can able to simulate all the things, but if you want to change it, the valve characteristics, like it will be normally open, so while that power cut it will be open, like that all the parameters we can't able to do it in this. So which will be done it in CTE only. So basics parameters we can able to test it in this without CTE also, without importing from that COMAS VNITs also we can able to test it in this. So which all basics we want to train all the things. So if you want to do that basic testing, all the things also possible to do it in this SIMIT. And then here we have a couplings is also there. So whatever couplings you want, you can able to couple with all the datas. So for simulation we have a SIL, we have a virtual controllers, and then we have a PLC sim, advanced PLC sim is there. So if you want to use that real controller, we have a OPC, UADA, and then real SIMIT unit is there. So through that we can able to connect all the data, and then we can able to do that simulation in this test itself. No need to go for a real hardware to done that testing of your implemented any ideas in your controllers, all the things also. We can able to test it here also possible in this. So the signals connectors oriented data will be comes under that all this OPC, UADA, all the data will be comes to that signals and inputs and outputs. So we will just map with this all the things in that signals. So we can able to send receive a data, all the things. If you want to send that level data from one place to another, all this also possible in this. So here we have one thing is basics. In Chem basics we'll have that basic oriented simulation which will be done inbuilt parameters itself. If you want to do it simulation with that outside, any controllers, all the things we have to do it with this FlowNet libraries. Under that we have all the pump which will be having that data which will be sending from outsources, all the things is possible in this. So if you want to driver controllers, we want to use, all these are available in this. Under that motor, so motor controller we have, so we can able to use this one also. So this is a motor controller. So in this motor controller we have a press to start, press to stop button. So here you can, this is one controller, so which we can have different modules, and then we have a start button or stop button. Here we can hide this button only, we can able to just on and off all the things. So running status also we can able to monitor. So for that I am just using that through PLCs or manually we can on and off. So here I am using that manual switch button. So push buttons or switches to on that. So if you want to do it with that PLCs also, like here the same signals we have no. So these signals we can able to give it is there, give it into there. So this I am just using these tools. So this is for on and off. So signal I am giving from that PLCs. So whatever the signal I am receiving, I will give it to that set point. So depend upon that PLCs, the pump speed may varying using that set point. So start and stop button will be available in my hand, push buttons like that, switches, whatever that which will having in that connectors, controls we can able to do it in this itself. So you can just try to draw any simple diagrams in that simulate, and then you can just simulate in this platform itself. No need to go for outside all the things. So I am just close all this. So here I will just connect with Y with this to this one. So this wall I no need this one also. So I am just having that one tank. So now currently I am using that normal tanks. After that, if you want, we can able to connect all the tanks. So here I am just adding that parameters, number of connectors. Here we have putting it into the 2. So then we have a 2 connectors. So if you want to move that connectors, you just press that alt, and then we can able to move that connectors, all the things from one place to another. It will be done using that alt tab. So once you created it, we can able to after that pump varying the pump speed, I am just putting another one tank. So here volume, length, all the things I have just changing is 100 meter cube. So reservoir tank will have that more volumes. Here we have a volume as 20. So height will be a 10 like that. So I am just connecting one measurements. So level indicator we can able to connect it here. So here just we will go with nearby that red point, it will automatically generate a plus connection line. So no need of this valves also. So once you create like this, you can just here we can able to put it as an parameters itself. So initial percentage, I am here putting as an 100%. For this initial percentage 3, okay. So I am just starting this demo. We can able to run through all the things. So here one connector is available. So for that I will change it into 1. So I am just on this one. So level will be increasing in this. So if you want to see that water is flowing, that pumps also we can able to view in this state. Show flow, yes, true. But in pipelines, we can't able to see that flow rates, all the things. So once you on that, it will be showing that flow rate is there. So here that how much flow is going, level is filling, all the things we can able to monitor from here. So like that we can able to do that small simulation, all the things also possible to do in that summit. So from basics we can able to simulate more larger things also possible in this. So from PLCs also we can able to send all the data and receive all the data can be also possible in this simulation. So this one time simulation we can run up to that 45 minutes. So no issues for it will be run. So it will get filling in just 15 minutes or 10 minutes. So like that of simulation we can able to do. So if you want to test that maintaining that level, all the things also it will be done it in 50 to 20 minutes. So like that we can able to. Okay. If you put that, it will just an indicators only. So level indicator. So once you want to cut off that level, all the things we need to put a sensor. So here we have a measurements in that we can able to put it in this also. We have a sensors which will cut all the data also possible in this. So through that we can able to send all the data to PLCs, all the things. Can able to connect it here. It's not connecting. So wall for this I will need this type of tank. It's in here. So this will give here. So here we can able to get that level sensor data. So through that we can able to send it to PLCs, all the things is possible. So for that we need a converters, anything in standard we have a analog to basic, integer basics. Conversion. So under that conversion, analog to integer converter is there. So if you want to change that what values you want to change, you can just click this with that analog. So through that integer we can able to send the data to that PLC, all the things. So once you get it all the data, we can able to stop and control all the things also possible in this. So we have a connectors in that. Sensor data will be given to that input of that PLC. So I am just clicking that input. So it will give to that input sensor to that signals. So through that we can able to connect all this. Now we can able to send the signal to the how much level is filling in the tank. Like that we can able to send it to your controller like this. So there will be all math functions or converters, all the things is available in that standard libraries. So if you want to do it in your manually, here itself also possible in this. So here inbuilt AND gate logics, if you want to do it, that logics also we can able to do it in this. Binary logics is there. AND gate logics, if you want to both the things high, then we want to start that pump. So like that possible, also possible in this. So you can connect with this here. So for input we have two types of high. So once you have a limit switches or anything else in the tank, so once you get the two limit switches high, it will on that motor. Like that also possible to do it in this programming inbuilt that SIMIT itself. No need to go for outside for programming all the things. Basic programs and then conversions, and then if you have a multiplication and then compare values, all the things can be, we can able to do it here, because PLC will send that 4 to 20 milliamps like that. So for that we need to convert it, that integer values to that analog values. All the things also possible to do for conversion oriented things. Basic oriented standard libraries also there. So through which we can able to convert all the data inbuilt platform itself. So you can just try to create any diagrams in that SIMIT SP demo, and we'll try to do anything. In YouTube itself, there will be many videos available for SIMIT, and then walk inside all COMAS oriented things only, that SIMIT only we have all the working procedure, all the things we have. So this one you can see in this how to install basic lamp switches. So line by line it will they will have that how to create all the things also available in this function interfaces. Like that all the things is there. So from here we can able to how it will be transfer all the datas, drives, and then we have a PLC oriented things, how it will be connecting with that PLC. All the data will be available in online itself. So you can just go through that online itself, you can able to implement in this SIMIT. But for comas or walk inside, there will be nothing in that art. So and then comas walk inside will have a VR headset. It will be having that MetaQuest models also. We can able to implement compatibilities there. Through that we can able to view with your VR headsets available in your markets also. Walk inside will not have in my laptop because of that graphics card issue. But Ubiq is there, so you can able to view in your mobile itself. There will be a Ubiq, we can able to see it here itself. So this is an software. Or you can just have it in your mobiles, all possible in this. So it opens, we will see here. ஓப்பன் ஆக மாட்டேது அதில். சரி, so in your mobiles itself, you have a AR platforms which will be software which will be available. Ubique is there, so through which we can able to find plant in data, inspection data, all the things in your mobile phone itself. Like you are having that tabs of your plant inspection, commissioning like that. So while you are going for inspection, what type of inspection? So data oriented things also possible in this maintenance. So whatever that available, we can able to see it in this. So this is an inbuilt one wastewater treatment plant. No, for that plant they have created VR and then they have created AR, all the things for a demo purpose for a pre-sales persons, all the things. So create a demo. So it will be available in that platform. For you, you want to create and upload in this. For that, there will be a charges for that. For using this, how much user you are going to use like that. For that AR, they will have a separate license for also available for different operator. They are going to use like that. Also possible to do in their mobile itself by reducing that paperwork of all the industries, also possible to do in this. So here we can able to see all the data. So any other doubts, whatever you want to get loan from me, or can ask. So like that we can have that what is that motor pump state, like that we will have. So once it done, we can just click on this. So like once you done like this, it will automatically update it in this platform. So like that we can able to give all the data manually with this help of that mobile itself. For VR oriented, so this is one of the safety scenarios they have. So we can able to do it multiple protocols also. We will do it in that summit. Comas walk inside. So everyone is going there or not, like that also we can able to do it here. So this is one industries they are walk through in that. So time is also going on that. So we like this we can able to create smokes or fire also possible in this comas walk inside. Through that we can able to do that black smokes or fire, whatever you want to create, we can able to create it in this. So on the time what we have to do, the training also possible to give in this. So comas is having that different types of usages, but it will have that some more limitations in that to get all the things. So here, once you see that you want to go and press that fire alarm. So fire alarm is located here. So once you click that fire alarm, so go to that safe assembly point. Everyone is has to move to that safe assembly point or not. So all the co-workers available in that virtual mode also, they have to move to that safe assembly point. So many of them are reaching that safe assembly point. It will showing that. So everyone is comes, then it will be that task will be closed. So like that we can able to create a many simulation oriented all the things also possible in this VR. Comas walk inside also possible in this. Uh, Submit. Yes. So this is what we can. I am trying to say that in that Comas platform itself, we can able to integrate all the things in single platform. So whereas Comas will have all the datas, it will having that SIMIT datas, and then it will have that PCS7 datas. Everything will be having in that Comas. So which will be sending and receive the data exchange from single platform itself. So first we can see with that SIMIT how it is having that valves, all the things. So same valve is here in that Comas itself. So here we can do with that SIMIT interfaces, we can able to export from here. So this is how we can able to export Comas PNID into that SIMIT. All the things that videos is available, but a little bit how to do all the things will be, somewhat it will be hidden, some things will be hidden. So once you get all the SIMIT values, we can able to assign that that Comas pump to that SIMIT values. All the things can be, once you done that, we can able to import it from here itself. So once you export it, we can able to do that control process also here in that PCS7. While you are doing that functional diagram, all the things also we can able to create it here. No, so that what also we can able to export it in PCS7 also possible in this. So how it will be structured, all the things also we can able to do it in this. So where it will be a DCS structure available. So like that, all we can able to find out, and then how that functional diagram of the wall. So the wall state, all the things also we can able to see in this platform itself. So this is an wall response. So here how it is going, all the things can be we can able to send. So these all data will be given to that PCS7. So functional diagrams, loop diagrams, which will be available in this, we can directly export it, and then we can able to import it from Comas itself. So Comas is one common platform. Through that we can able to get SIMIT data also, and then PCS7 data. So it is a database hub through which we can get all the informations in one platform, mainly in that. So how it is assembled in automation plant like this, in that controller, how much, what are the things is available. We can able to get it in Excel sheet data. Some data Excel sheet. Is possible to get. You need a one level plant or what pressure. How long you want that data? Like that you want. Yeah, we can able to get it all the datas, but we want to transfer all the datas from Comas only, because Comas will have that data storage, all the things. Yeah, we get it. Then they will work it out some possible of some mission and oh, okay. So we can able to import it, that XML export, we can able to import it here. We can able to generate a loop, all the diagrams here, all the logics we can able to import it here. So that wall control you can able to import it here. No need to create a wall controls or programs for DCS also, no needed. And then hardware configuration is also came as much from there itself. So this is what these three can be integrated and then runs simultaneously. So here we can able to couple with that virtual controllers also. So here no need of any hardware, nothing is needed. So we just import that modules from PCS7. So we can able to get all the datas. So charts also we get it from there itself. So this is only for reactor tank. So after that it will going for some other places. So small purpose, small thing we can just simulate it and then we can integrate all the things and then do for a demo purpose. No, this is SIMIT only. So SIMIT can be interfaced with any virtual controller, all the things. So with the PLC is also possible, with the DCS more things via virtual PLCs, PLC SIMs. So like that also possible to connect with that SIMIT. For simulating, if you are a test your code and deploy in your Raspberry Pi any AI algorithms, you want to test it in your real plant, it will be very difficult. So if you want to test it in SIMIT, also possible in this. Like that we can able to do. So no. Do you have any queries you ask? Yes. What? Software's cost? I don't know that. I don't know that correctly. For educational purpose, they have a different, very less cost availabilities. Huh? Range. It will be a yearly licenses only. We have to renewal. But SIMIT is a perpetual license, I think. SIMIT will have the perpetual around 3 lakhs one user. For no, perpetual. Lifelong. Perpetual. So it will be working with your exact version, which version you can buy. So same version you can able to use it for lifelong. Updated means you can't able to update. You can't able to update. So if you are getting SIMIT 10.0, that's what I am using 10.0. So now it is 11.2, like that it is coming up. So I am having the 10.0 license, so I am just go with that 10.0 only for live song. New. Yeah, but the licenses terms and conditions are like that only. For 1 year only they will give that upgradation, all the things. After that they won't provide any upgradation, all the things. You have to use that same license up to that lifelong.